Business Mathematics Chapter 1. Business mathematics involves a lot of arithmetic, some algebra, geometry, and other mathematical topics. But the major portion of business math is simple arithmetic. The main thing to know in business math is that, while there are lots of different formulas, knowing when to apply what and to which formula is the secret. Patrick. Keep in mind fractions, decimals, and percents form the basis of business math. I'll repeat that again. Fractions, decimals, and percents form the basis of business math. In part 2 of the book, you'll find fractions popping up in various formulas. I'm sure you probably still remember how to convert fractions to decimals and then to percentages, but I'll review it for continuity's sake. The best example is this. The simplest fraction is 1/2. As a fraction, 1/2 is written as 1/2, 1/2. To find the decimal, you divide the numerator by the denominator, which gives you 0.5. That's the decimal. To find the percent, simply multiply the 0.5 by 100, which gives you 50, or in this case, 50%. Why is this important in a real-world scenario? For example, if you're going to buy or sell a particular product at half price, then you know it's 1/2, which is 0.5, which is 50% off. So now you know if the item normally costs $100, then the new price is $50. Or if it was $35, now it's $17.50. While these are very simple scenarios, the main thing is that knowing how to convert from fractions to decimals and vice versa is important throughout business math. As the book mentions, decimals are the middle ground between fractions and percents. To convert a fraction to a decimal, you divide the numerator by the denominator. Alright, hopefully that's making sense so far. Let's move on to capitalizing on patterns and formulas. Patrick, according to the book, the main trick to working with any formula is knowing what the different variables stand for and how to perform the mathematical operations involved. Here's a familiar example. To find the area of a triangle, multiply the base times the height, then divide by 2. So, the formula is written as A equals BH/2. Okay, let's move on to capitalizing on patterns and formulas. Part 3 and 6 of this book shows you some formulas related to loans, mortgages, and other financial manipulations. Patrick, someday you're going to want to buy a house, cars, etc., so it's important to understand the basic ideas presented here. Keep in mind when they say mean average, it's the same thing as just saying the average. You get the average by adding up all the numbers, then dividing by how many numbers you used. For example, if you want to find the mean average for the numbers 4, 6, and 11, add them all up, which is 21, then divided by 3, because you used 3 different numbers, giving you a mean average of 7. Median. To find the median of a set of numbers, you arrange the numbers in ascending order, and then find the middle value. For the set 4, 6, 11, the numbers are already in ascending order. So, the median is 6. Mode. The mode is the number that appears most frequently in a set of numbers. If there are multiple numbers that appear with the same highest frequency, the set is considered multimodal. If no number repeats, the set has no mode. Finding power in exponents. An exponent is a power. It's like shorthand algebra. It tells you to multiply something by itself over and over again. So if you see 3 squared, that means 3 by 3, which is 9. If you see something that says 3 to the power of 3, then that'll be 3 by 3 by 3, which is 27. If you see 3 to the power of 4, then it's 3x 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 3, which is 81, and so on. Exponents are fundamental in compound interest, formulas, and amortized loan formulas, as well as other financial formulas. Here are some basic rules for different operations involving exponents. When you're multiplying the same base, you add the exponents. For example, if you have 8 to the power of x times 8 to the power of y, then that equals 8 to the power of adding x plus y. So if you have 2 to the second power times 2 to the third power, that gives you 2 to the fifth power because you're adding the exponents. Hopefully that makes sense. When you are dividing the same base, you subtract exponents. So 10 to the 10th power divided by 10 to the 5th power equals 10 to the 5th power because you subtract the exponent of 10 minus 5, which gives you 5. Remember, these examples listed here of adding or subtracting the exponents are only if the base is the same. To multiply the exponents, you would have to have a number, in parentheses a to the power of x, and then, outside of the parentheses, all of that to the power of y. Then you will multiply the x and the y to give you the new exponent. For example, inside the parentheses you have 10 to the 2nd power. Outside the parentheses, all of that is to the 3rd power. You multiply power times the 3rd power, giving you 15, so the answer is 10 to the 15th power. When handling negative exponents such as a to the power of negative x, you move the power to a denominator and change the negative power to a. Positive power, so it would look like a fraction of 1 over a to the power of x. Hopefully that makes sense. If not, let me know and we can discuss. When you're dealing with roots and you're changing the root to a fraction, here's the best way I can explain it. The square root of a equals a to the power of 1/2, or you could say 0.5, both of which equal an exponent of half. Use the rules involving multiplication and root to simplify 9 to the power of 3/2 times the square root of 9. Step 1. Change the radical to a fractional exponent. So the square root of 9 in exponential form is 9 to the power of 1/2. Next step is, since the base is the same, add the exponents. So 9 to the power of 3/2 plus 1/2 equals 2. So that makes it 9 to the power of 2, also known as 9 squared, which equals 81. Page 13. On this page, they explain how compound interest works. Although the book doesn't explain it this way, I'm going to explain the differences between simple interest and compound interest so you have a better understanding. Now, this is important, so you got to get this. In the example I'm providing, let's say you're investing $100 at 5% simple interest for 3 years. That means at the end of every quarter, which is every 3 months, you're going to get $5. There are 4 quarters in a year. Multiply that times the 3 years you're going to leave your investment there. That means your money will be working for you for a total of 12 quarters. $5 times 12 quarters gives you a return of $60. At the end of 3 years, you would have your original $100 plus the $60 you earned, so that's a total of $160. Okay, that's how simple interest works. I wanted you to understand this so you could compare it to the beauty of how compound interest works, which makes you way more money. So pay close attention. Let's look at the formula for compound interest on page 13 of the book. As you can see on page 13, the formula for compound interest is A equals P, then in parentheses 1 plus R over N to the power of NT. Now, here's what all that means. A equals the future value of the investment/loan at the end is a set time, your original investment as well as the interest you earned. In other words, how much money you'll have at the end of a particular period of time. This is written as the letter T. P is the principal investment. In other words, the amount you initially deposited or borrowed. R is the annual interest rate, written as a decimal. For example, 5% equals 0.05. The letter N represents the number of times the interest is compounded per year. For example, if it's compounded annually, then the letter N equals 1. If compounded quarterly, then N would equal 4 because there are 4 quarters in a year, every 3 months. For our example, we'll stick to quarterly, which is 4. As mentioned above, the letter T is the total number of years the money is invested or borrowed for. In our example, we'll say 3 years. So these are the steps to using the formula. Step 1. Convert the interest rate, R, from a percentage to a decimal by dividing by 100. In the example above, R is 5%, so it is rewritten as 0.05. Step 2. Divide the annual interest rate, R written as 0.05, by N, which is the number of compounding periods per year. In this example, it's done quarterly, so the number is written as 4. So 0.05 divided by 4 equals 0.0125. Add 1 so that gives you 1.0125 inside the parentheses so far. Step 3. You multiply the letters N and T located outside of the parentheses. We'll say it's compounded quarterly, so N equals 4. Because the time frame is 3 years, T equals 3. So NT equals 12. Step 4. Now you multiply the 1.0125 inside the parentheses to the 12th power. So now, inside the parentheses, it's equal to 1.159274. Step 5. Take P, which equals $100, times 1.159274 inside the parentheses, giving you an answer of A equals $115.93, rounded up. In essence, the formula shows how an initial investment grows over time by earning interest on both the initial principal and the accumulated interest from previous periods. Patrick, I recommend you practice this formula by coming up with your own scenarios, then checking your answer with ChatGPT. Once you understand the formula, it's easy to figure out.